Hello guys, and welcome to my channel. Today we're going to look at how to calculate the minimum and the maximum stress of a loaded beam. Please note, if you are new to this channel, don't forget to subscribe and like the channel, and also leave a comment. And one last thing, don't forget to hit that notification bell so that you don't miss any upcoming videos. So we've got this beam, that is the loaded beam. We've got the point load PL and UDL for uniformly distributed load. So as you can see, the beam has got the solid part and this part which is of free space. Okay, that is the void here. So the height is 0.7 and 5 meters long. So we've got also some given information, that is the point load of 10 kilonewton, uniformly distributed load of 12, and length of 5. And we've got that modulus of elasticity is 210 gigapascals, and IXX moment of inertia of that one, and Y bar, that is the send rate. So we're going to use this formula on how to calculate the stress, and this is the stress theta, okay, and then this is the send rate, and IXX moment of inertia, and M is the bending moment. So firstly, we're going to calculate for the maximum stress. So let's solve this one. Theta max for maximum stress, theta max will be equal to, let's rearrange this equation and make theta the subject of the formula. It will be M multiplied by Y over I. But as you can see, something is missing here. We don't have the bending moment for this thing. So what we're going to do, we're going to calculate for the bending moment. So M, let me say M total. Why? Because got the point load and the uniformly distributed load. So it will be equal to M U G L and also M for the point load. That is the bending moment for the point load and the bending moment for the uniformly distributed load. So for the uniformly distributed load is W, let me say W with this thing now, L squared over 8, and for this one, for the point load, is WL over 4. Okay, so we're going to substitute here. For the uniformly distributed load is 12 kilonewton per meter. Okay, so we're going to use 12 kilonewton, that is, and L, we got L of 5 meters, so it's 25 here, and we're going to divide the rest with 8, and we're going to add for W. We've got point load of 10 kilonewton, is 10 kilonewton, and we've got length of 5, and we're going to divide by 4. So if we're going to punch these figures in a calculator, we get 50,000. So for the moment, for the bending moment, we got 50,000. So we're going to substitute in our equation and calculate for theta max. So theta max will be equal to 50,000, and for Y, we got Y bar 0.37, 0.377, right? And we're going to divide by I. We got that one is 0.01196. Okay, so we're going to use our calculator and see what we get here. So if you punch these figures in the calculator, we get 1.56 megapascals. So this is the maximum stress for this beam. Okay, so let's go now and calculate for the minimum theta, that is the minimum stress. So it will be theta min will be equal to, use the same equation. So for M, we got the M and the Y and I. So it will be M multiplied by Y over I. But now there's something that I want you to know for minimum stress. That is, this y for minimum stress will be, let me say ym for y for minimum. Ym is equal to d and subtract by y bar. What is d? D is the height of the beam, that is 0.7 meters, and y bar, that is the send rate. Okay, so let's do this. D is 0.7 meters, 0.7, and we're going to subtract y bar is 0.37377. Okay, so if we are going to punch these figures in a calculator, what do we get? We get something like 0.3262. It's 0.3262 meters. Okay, so this is the y we're going to use in this equation now. So theta mean will be equal to m is 50,000. Okay, and y, that is the y that will go there, is 0.3262, and we're going to divide the rest with I, that is the ixx. Okay, ixx is 0.01196. So we're going to use our calculator and let's see what we get here. So theta minimum will be equal to 1.36 megapascals. Okay, so this is how we calculate the minimum and maximum stress for a loaded material. So everything is just simple, but one thing I want you to note is you have to know these equations. You have to know them so sure. So thank you for watching, guys. Hope this video has been useful to you. Don't forget to subscribe my channel and hit that bell so that you don't miss any video. Thank you for watching. Bye bye.